Hi everyone, I am Madhubhasri. Welcome back to my YouTube channel. In this video, we are going to learn about list stack, a simple but powerful data structures. If you have ever stacked plate, you already know the idea. By the end of this video, you will be able to explain what is list stack, how it works, and how we can implement with it simple example. Whether you are beginner or just new here, don't worry, I got you covered. Let's get started. Okay, before we move into the list stack, what is stack? A stack is the one of the most basic and powerful type of abstract data structure in computer science. Think of it as a special container that holds data. What makes it special is the rule it uses for adding and removing data. Key idea about it: it is a sequential structure, meaning you can only access the item that was most recently added. There is true principle, but in here we will only talking about LIFO principle. LIFO principle meaning last in first out. Basically, in real life, think of a stack of plate. When you put clean plate on the counter, the last plate you place on the top is the first one you will grab when you need to use one. You can't easily reach the plate at the bottom without moving all the one on top of it. When it comes to conceptual analogy, there is few real life example. Cafeteria tray, a file of books, and undo button. Undo button. This is very casual programming example. Every action you take, like typing, deleting, formatting, every action you take is pushed onto a stack. When you hit undo, the last action performed is the first one that you get rewarded. Alright. Essential stack operation. There is 4 operation: push, pop, pick, and IsEmpty. Push is basically to add new element into the stack. This also increases the size of the stack. And second one is the pop. Pop, the operation to remove and return the element currently at the top of the stack. Key point is it always pop the top element because it can't reach other one without pop top element. Peak operation meaning view the element without remove or without removing. Example, you can look at the top of plate without removing. You can look at plate's color basically. IsEmpty. When you pop an element from the stack, you should check the stack empty or not. The stack is empty, you can't pop an element from the stack because that stack is empty. There is no element to pop. Basically, IsEmpty is a Boolean function that checks if the stack contains any elements, casual for avoiding error when trying to pop from empty stack. Okay, here list stack and dynamic stack implementation. The main topic is here implementation. While you can build a stack using a static array, the list stack is often the preferred and more powerful method. The problem with array stack used to fixed size array. If the stack gets too full, the array has to be manually resized. This is a problem when the maximum size the stack unknown or highly variable. The solution is list stack. What we talking about? The list stack offers high flexibility by utilizing power of linked list. What is linked list foundation? The list stack builds the abstract stack structure on top of dynamic singly linked list. Key concept: the top of the stack always corresponds to head of the linked list. Push, pop, and peek. Second one, node structures. In a list stack, every single element of data is stored inside a special container called node. Encapsulation. Each element is encapsulation within a node. A node typically contains two parts: the data payload itself. Second one, the pointer. When it comes to the dynamic advantage, this is the main benefit and why list stack is often preferred over array stack. Because linked list allocate memory dynamically as needed, a list stack has incredible flexibility. Second, it can grow, shrink identically based only the available system memory. Avoid overhead. This is completely avoid the common limitation and overhead of array-based resizing, making operation generally faster and more reliable when stack size unpredictable. List stack versus array stack. Choosing between list stack and array stack depends on the application specific need, focusing on memory management and performance predictability. In list stack, dynamic size grow without limit, no overflow issues. When it comes to array stack, fixed sizing requires a for defined maximum capacity, risks of overflow, and also you can see memory overhead, efficiency, and data locality. Why list stack avoid resizing issues? The primary benefit of list stack is avoiding the complexity of array resizing. The problem with array stack: when an array stack becomes full, the system must create a new large array, copy all exit element, and then dispose of the old array. This copy operation is expensive. Resolution is the complexity. The list stack is solution. List stack simply create new node and updates pointer, completely avoiding the costly copy process. Finally, operation summary. Push create new node, set its next pointer to the current top, and update top to the new node. When it comes to pop, save the data from the top node, update top node to the node referenced by the current top, next, and return the saved data. Alright, today we explore this stack in Java and how to implement a stack using linked list. We saw that stack follow LIFO principle, and also we practice key operation in list stack like push, hop, IsEmpty, p. I hope you learned something from this video. If you found something helpful, don't forget to subscribe for more video on data structures. And thanks for watching.